Hello, in this video I'm going to be doing a level 3 or difficult factor label problem. So right here we got question 16. Roll of aluminum foil contains 75 feet squared and weighs 12 ounces. Aluminum has a density of 2.7 grams per centimeter cubed. What is the thickness of the foil in millimeters? And then they give us some conversion factors, and they do give us one conversion factor from the previous problem on this sheet that will come in handy. Alright, so we want to find thickness. So just drawing a picture. Well, I don't know if I should draw a picture, but there we got length times width equals our 75 feet squared, and then there's that thickness right here that we're looking at. How thick is that aluminum foil? Alright, so we need length times width times height. Length times width times height equals volume. That's a good place to start. We got 75 feet squared. That's length times width. So what I'm going to do is I'm just going to assume that we're making this into equivalent to one big square. So 75.0 feet squared, and I'm going to take the square root of that to get length times height, basically. Alright, so I take my calculator out because there's no way you could solve this without one. Well, there is, but it'd be very hard. We got 75 and we're doing a square root. It's 8.66. 66 feet. And we got rid of that square. Now it's just feet. Alright, we got density right here. We're definitely going to need this eventually. And it's in centimeters cubed. So it'd be good to convert feet to centimeters at this time. Right, so I'm going to multiply by centimeters on top and feet on the bottom, and just so happens we've got a nice little conversion factor right here. For every 1 foot, there's 30.5 centimeters. I'm going to get my calculator out, take my number in feet, times it by 30.5, divided by 1, and it gives me 264.13 centimeters as feet cancels out. Alright. Next, I can plug this into my length times width times height equation. I've got 264.13 centimeters. My width is, again, 264.13 centimeters because we're just assuming we're putting this whole thing in one big square. And then thickness, we don't have that yet, equals my volume, and we don't necessarily have that yet. Alright, so we're going to come back to that equation later, but we've got 12 ounces. 12 OZ, and our density is in grams, so why don't we just convert that into grams? Ounces to pounds, there's no gram conversion, but if we look back, pounds to grams. So we're going to convert ounces to pounds, pounds to grams. A whole bunch of stuff going on here. So I'm going to put what I want on top, which is 1 pound, and what I don't want on the bottom, which is 16 ounces. 12 divided by 16, I take my calculator out, 12 divided by 16, gives me 0.75. Cancels out, pounds, and technically I can do two conversion factors right after each other. I don't have to stop right there. We got 1 pound for every 454 grams. So 454 grams is on top, 1 pound on the bottom, pounds cancels out. I'm going to take my 0.75 times 454. Gives me 340.5 grams. Alright, now that I have my grams, and I've got two of my lengths, I can use this density equation. So density is 2.70 grams per 1 centimeter cubed. And this is equivalent to 340.5 grams per, I'm not sure. So this volume is what I'm going to ultimately plug into my equation that will get my thickness. But what I'm doing is proportions. So this is the density for every 1 centimeters cubed, or how many grams I have for every 1 centimeter cubed. What if I had 340.5 grams, like in this example? How many centimeters cubed would that be? Alright, so 2.7 divided by 1, multiply both sides by v. That's 2.70. V equals 340.5. Divide both sides by 2.7. 340.5 divided by 2.7 gives me 126.1. So my V is 126.1. And what are my units? Since I was in centimeters cubed here, I'm in centimeters cubed here. Alright, that's my volume. I plug it into this problem. We're going to go right back here. 126.1 centimeters cubed. And now we can take our 126 and divide both sides by our 264, and again divide both sides by our 264. Type that in the calculator, 126.1. Oh yeah, 264.13. Enter. I'm going to then divide it by 264.13, because there's two of those. And that gives me a thickness of 0.0018, and we're talking about centimeters because we just divided by centimeters 2 times from our centimeters cubed, so it's just centimeters. And just double checking, I'm just reading this problem. It says, what is the thickness of the foil in millimeters? So you would think we would be done, but they got to ask us in millimeters. We're in centimeters. So that's where we do just a basic factor label metric conversion. We want to convert to millimeters, put that on top, centimeters on the bottom. You might have it memorized or you might not, but if you have that King Henry died by drinking chocolate milk acronym memorized, you know that milli is right here and that centi is right here. We're going from centi and we're moving our decimal 1 time to the right. And if we remember, we always give 1 to our largest prefix, so if we take 1 and move decimal once to the right, that's 10. So we got 10 mils, or 10 millimeters for every 1 centimeter. 0.0018 times 10 divided by 1 gives us 0.018. Just double checking our sig figs, we got 3 sig figs, 3 sig figs, so I'm going to have to put a 0 after this guy to make it correctly rounded. And that is my final answer. That was a lot of work. That's why it's a level 3 or a difficult factor label problem. You might see something like this on the test as a challenge question. If you can do this, you can do anything.